Adding and subtracting rational expressions. Rational expressions are just complicated fractions, right? So when we talked about multiplying and dividing, we treated them just like we would fractions. Cross-reduce as much as we could, deal with what was left. When we are adding and subtracting fractions, in order to add and subtract, you have to have a common denominator. So adding and subtracting fractions is more complicated than multiplying and dividing. So we have to have a common denominator when we try to add or subtract fractions or rational expressions. So the first thing that we need to talk about is finding least common multiples so that we can find least common denominators. Now, you don't have to find necessarily the least common denominator. We can find any common denominator that we want, but it's going to make it easier if we can do it the smallest way possible, okay? So finding a least common multiple of two numbers means we're looking for basically the smallest possible number that they can both be multiplied into. Okay, one of the ways to do that is to factor them down, like using a factor tree, and figure out what their common factors are and what their common factors aren't. Okay, which is basically the method we're going to use for this. We're going to look at what 12x squared y times x squared plus 2x plus 1 looks like as factored all the way down. And we're going to look at 18xy cubed times x squared plus 5x plus 4 factored all the way down. And look for what they have in common and what they don't have in common. So if we factor 12x squared y times x squared plus 2x plus 1 all the way down to its basics, 12 breaks down into 4 times 3, which breaks down into 2 times 2. So we have 2 times 2 times 3 times x squared times y. Factor the x squared plus 2x plus 1. Two numbers that multiply to 1 have to be 1 and 1. We want them to add to 2, so they should both be positive. $18 breaks down into either 6 times 3 or 9 times 2. 9 breaks down into 3 times 3. So we get 3 times 3 times 2. We have an x. We have a y cubed. X squared plus 5x plus 4. Two numbers that multiply to 4. We either have 1 and 4 or 2 and 2. That add to 5, it has to be 1 and 4. So x plus 1 times x plus 4. Okay, when you are finding a least common multiple, we need to have everything represented from both sets of numbers, okay? So we have 2 2's here. We have 1 2 here. We take the larger, which one has more? Okay, so we have to take 2 2's. This one has a 3. This one has 2 3's. So we have to take 2 3's. The first one has 2 x's. The second one has 1 x. So we have to take 2 x's. First one has a y. Second one has y cubed. So we have to take y cubed. The first one has x plus 1 squared. The second one has just x plus 1. So we have to take x plus 1 squared. This one doesn't have an x plus 4. This one does, so we need to take an x plus 4. Now, we don't have to completely multiply all of that out, but I would like to see us do 4 times 9. So 36 x squared y cubed, and this stuff we can just leave like this. So if we look at factoring these, it's not necessarily that we can break them down into numbers like we did in the last one. We just have a binomial. We have two terms here, and we're looking for what do they have in common. They both are divisible by 2. So we can take out a 2, which leaves us with x plus 2. X squared minus x minus 6. We're looking for two numbers that multiply to negative 6 and add to negative 1. And our options would be 1 and 6, 2 and 3. The one that's going to give us a difference of 1 is 2 and 3. So x minus 3 and x plus 2. So there's our factored forms. So our first term has a 2. This one doesn't have any numbers, so we don't have to worry about that. It has an x plus 2, which this one also has an x plus 2. So we've already got that covered. The second one has an x minus 3, so we have to take that from that. So our least common multiple would be 2 times x plus 2 times x minus 3. So we'll talk for a few minutes about adding rational expressions. If we have something like x plus 1 over x minus 1 plus negative 2 over x squared minus x. So we have a fraction plus a fraction, complicated fractions, right? In order to add these fractions together, we have to have a common denominator. Okay, so what you're going to do is we're going to try to find the least common denominator of x minus 1 and x squared minus x. So you are going to, as we have been doing a lot, factor, 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 factor. Now, x minus 1 really doesn't factor. That's as simple as it's going to get. X squared minus x, do they have anything in common? They have an x. So if I take out an x, I'm left with x minus 1. So one of my denominators is x minus 1. My other denominator is x times x minus 1. So they both have an x minus 1, right? What is this one missing, though? An x, right? They both have the x minus 1, but this one has an x and this one doesn't. So our common denominator is going to be x times x minus 1. So this is going to need to be multiplied by x, and this is going to need to be multiplied by x. So we have x times x plus 1 minus 2 over x times x minus 1. Now, I would multiply the numerator out, see what we end up with. Yes. So x times x plus 1, we would distribute that first. So I'd have x squared plus x minus 2 over x times x minus 1. What we want to see is, will this simplify at all? How do we know if it's going to simplify? What do we have to do? So on the top, we need to do our thing that we do pretty much every single one of these problems repeatedly. Factor, 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 factor. So x squared plus x minus 2. How do we factor that? Find the magic numbers that multiply to -2 and add to +1. The only numbers that multiply to 2 are 2 and 1, right? For the 1 to be positive, we would want +1 and -2. Or, I said that backwards. +2 and -1. So this would be x plus 2 times x minus 1. And what happens? The x minus 1s cancel. So we are left with x plus 2 over x. And based on our denominator, we had an x, so x can't equal 0, and we had an x minus 1, so x can't equal 1.